Hello, everyone. Welcome to this webinar on Southwest drought conditions and resources. My name is Emily Elias. I'm the director of the USDA Southwest Climate Hub, a group working to support farmers, ranchers, foresters, and communities responding to extreme weather events such as drought. Next slide, please. These briefings began during the 2020 Southwest drought as part of the Southwest Drought Learning Network's monitoring and impact reporting team. And they'll continue as long as there are areas of extreme or exceptional drought conditions in the Southwest United States. I'd like to acknowledge my co-host, Joel Lisenby. Joel is the Regional Drought Information Coordinator for the Intermountain West and Southern Plains regions of the National Integrated Drought Information System, or NIDIS. If you're not familiar with NIDIS, you can learn more about it at drought.gov. The Drought Learning Network links climate service providers with resource managers and resource managers with one another to increase landscape and community resilience to current and future drought. The next virtual quarterly meeting of the DLN will be on September 14th from 2 to 3:30, and all are welcome to attend. Next slide, please. To begin, I would like to acknowledge that the land each of us is on today is the ancestral lands of tribal and indigenous cultures, and to pay my respects to their elders and chiefs, both past and present. I welcome all tribal and indigenous peoples who are joining our webinar today. We think it's important to provide this acknowledgement because the narratives of our land and region have long been told from one dominant perspective without full acknowledgement of history. This is also important because many of us are resource managers and we strive to manage the land and water well for future generations. Thank you for your attention and respect in acknowledging this important history. Next slide, please. Before we get started, we'll cover some logistics. For this webinar, everyone is muted and the webinar is being recorded. It will be available from the NIDIS YouTube channel and drought.gov/webinars. The format for today's webinar will be a presentation by each of our invited experts, followed by a time for questions. If you'd like to ask a question, you may do so at any time by typing your question into the questions box. Following the two presentations, the questions will be moderated by Joel Lisenby. Next slide, please. So today we have two experts, and I'd like to welcome and introduce today's speakers. Curtis Regante is a climatologist with the National Drought Mitigation Center, where he also does research on observed trends in climate and drought data. He has a background as a meteorologist studying severe storms before he ventured into the climate side of atmospheric science. Curtis doesn't spend all his time analyzing climate data. He also enjoys hiking, storm chasing, and has some good stories there and good books. Don Browning is a research ecologist with the USDA Agricultural Research Service at the Jornada Experimental Range in Las Cruces, New Mexico, and considers herself a bridge builder. Her research bridges the fields of ecology and remote sensing to understand mechanisms governing ecological processes, such as shrub proliferation in grasslands. In her projects, she aims to bridge technology with on-the-ground needs of producers and managers. Dawn is inspired to rekindle our childlike curiosity with the natural world so that we may reconnect as a means of saving it. So with that, we'll turn it over to Curtis to hear about current conditions and drought outlooks. Curtis?
Great, thank you for having me. We'll go ahead and just jump right into the current conditions. First, I need to show my screen. So I want to make sure, can everyone see a screen that says NOAA NIDIS Southwest Drought Briefing?
Yes, looks great, thanks.
Cool, okay, thank you. I haven't rarely used GoToWebinar and never presented using this before, so glad to hear that it's working. All right, so we'll just get right into the current conditions. So kind of going to start off on the negative end of things. So this is a map from NRCS showing the percentiles through the whole period of record for the end of July for selected reservoirs across the Western United States. And not really a surprise, as you can see, most of these are on the low end of the scale. Notably, Lake Powell is sitting at the 3rd percentile right now here along the Utah-Arizona border, and then Lake Mead, well, the data point on this map is missing. I'll go ahead and show a graph from that in a moment. Also, the conditions there in terms of reservoir levels are not great, which again is just a signal of how dry this region has been both over the last couple of years and really across the last couple decades as we've moved into a bit of a mega drought. And I'm trying to advance my slide, apologies here. So yeah, this is a recent graph of July elevation levels at Lake Mead, and as you can see, that is currently sitting at 1,040 feet in elevation, its lowest value on record. And so just this quick look, and I'm showing you guys things that I think most people on this webinar probably have already seen or know, but this is just a historic look at the high and low elevations annually at Lake Mead, and then the last 20 plus years of the US Drought Monitor across the Colorado River Basin, River Forecast Center area. And so what that's showing is pretty much up through 2000, with a few blips up and down. We've had relatively higher constant levels at Lake Mead, and then since 2000, again with some interannual variability, we've generally seen a decreasing trend in levels there. And unfortunately, that's continued. So getting into some remote sense products here is another way to show that the area, much of the Western United States and particularly the Southwest is still seeing long-term drought conditions despite recent wetter conditions in some areas. These are wetness percentiles from NASA's GRACE platform that estimates shallow groundwater. And what we're seeing here is, generally speaking, pretty low groundwater estimates as of August 1st in much of Utah, western Colorado, most of New Mexico, Arizona, and at least the southern half to 2/3 of California. So going back just through the last roughly year or so, or at least half year, really a look at the water year, I wanted to pull up a couple of maps of snow water equivalent data from NRCS just to show kind of how we got to where we are right now on a shorter term. And so what we're seeing here, this is as of April 17th. So I'll show this and then the peak snow water equivalent values that, again, with some local variability, for the most part in the Southwest, we've been seeing near or below normal snow water pack equivalents as of mid-April. As we move forward here, just looking at the peak values from the water year, most of these were well below normal across much of the West. And so the amount of water obviously being held in higher elevations by snowpack was pretty limited again this year, which has also left us in a pretty bad spot before going into what's been a relatively active monsoon. And so this is just a quick look at COCORA's rainfall measurements from the last week. So through, I think, this morning, pardon me. And so what we're seeing is widespread amounts across Arizona, New Mexico, and parts of Colorado, even into parts of northern Utah recently, in Nevada, of at least an inch of rain, with some areas seeing over 2 inches, and in a few isolated spots seeing over 4 inches of rain over the last week. Again, this has some data holes too, so there may be isolated higher amounts over that time period. And looking over a bit of a longer period from July 8th through today, and we're seeing widespread amounts of 5 inches or more, with most areas seeing at least 2.5 inches where we have measurements across much of Colorado, New Mexico, and Arizona. And a few spots in southern Nevada have seen some higher amounts over the last couple months as well, or at least over the last month, pardon me. And so then this is some AHAPS estimates taken with a grain of salt. I know recently there have been some issues with radar coverage from the Grand Junction radar. You have your, on the left side of the page here, the scale so that you can get an idea of what these numbers mean. So you have certain areas that have been estimated to see at least 5 inches of rainfall, like we saw over the CocoRa's data. And so this is looking at roughly the last month's worth of data. This is what I was looking at last week when I was doing the US Drought Monitor author. So this is an example of what my ArcGIS map looks like sometimes when I'm moving the lines around. Obviously, usually I'll have more data that I'm looking at than just this. But again, in spots, pretty heavy rain has fallen over the last month. So pulling up some SPI maps now, courtesy of the Colorado Climate Center at CSU. So this is just a 30-day SPI through August 5th. And again, that based on what we saw in some of the CocoRa's and AHAP's data, no surprise that outside of a few spots here in southeast New Mexico and a few areas of central Utah, northern Nevada, most areas are seeing wet SPIs over the last month, some very wet. And as you're probably mostly aware, just across the border in California, we saw the second highest rainfall on record at Death Valley there. So again, only a few of these have actually occurred during monsoon months. Again, if you have August, the September one might have been associated with the monsoon, and then an August 5th from the 1930s. So again, really wet period recently associated with a pretty active monsoon circulation. And then going back 3 months, we're still seeing a wet signal across many areas, particularly in Colorado, Arizona, and New Mexico, excluding southeast and parts of east central New Mexico now. But you start seeing drier conditions already showing up in parts of Utah and Nevada at this point as we go out to 3 months. And another notable area, this is concurrent with some of the drought going on further east into the high plains. You're starting to see a pretty dry signal show up across northeast Colorado as well. So going back and taking both into account the low snowpack this year and the wetter monsoon, this is our water year-to-date SPI. So October 1st, 2021 through August 7th of this year, we're seeing kind of spotty conditions here. So some wetter values still show up in Colorado and Arizona, and a couple spots in Utah and Nevada, but more widespread dry conditions are showing up once you include the really very dry winter conditions that occurred in most areas. And where you combine less monsoonal rainfall with those dry winter conditions in east central and southeast New Mexico, you're seeing SPI here showing up in the D3 to 4 range in those high plains areas of New Mexico. And now just going back 2 years, this goes to show that despite the active monsoon this year, that's still in many areas a drop in the bucket right now, where much of Utah, Nevada, Arizona, New Mexico, and southwest Colorado are still seeing SPIs in the D2 to 4 range. And same map at 12 months, and you're kind of seeing a mix between really dry conditions last year, slightly wetter conditions this year, so a mix. And then when you account for temperature this year, again, with relatively above normal temperatures over the last 12 months, we're still seeing fairly dry conditions in most areas in the SPEI. So a few other products that we look at while doing the drought monitor. And this is from the end of July, our veg dry product. This is basically a statistical combination of NDVI data with localized drought indices. And again, this is showing outside of a few local areas that conditions are still quite dry across much of Utah, Nevada, Arizona, and especially east central and southeast New Mexico and northeast Colorado. Our quick dry product is not as dry, where most of the areas that are showing some signs of flash drought really are across now kind of east central, southeast New Mexico, northeast Colorado, with a more nebulous signal, and in some areas wetter across the Four Corners states. And again, this is the GRACE product that we showed earlier, but looking at our root zone soil moisture and near surface soil moisture. And so again, you kind of see a similar pattern show up with wetter conditions now showing up, especially in the near surface moisture across parts of Arizona, Nevada, Colorado, whereas drier conditions still exist in east central and southeast New Mexico. So quick look at temperatures and their effects on drought. So this is NOAA's eddy product, and so over the last 9 months, we are seeing, especially in the high plains areas, widespread D2 and D3 in terms of our evaporative demand as it compares to normal for this 9-month period, and then even some D4 showing up in southern Nevada and southwest Arizona, with slightly better conditions in other areas of the Four Corners states. And as we go more recently in time with the monsoonal circulation, a lot of areas have seen cloud cover and below normal temperatures, or near normal temperatures at least. And so across parts of the Four Corners, we're seeing better eddy conditions at 3 months, whereas southeast New Mexico is still fairly nasty. And then over the last month, again, some signal for below normal evaporative demand across the Four Corners, but still above normal into the high plains of far eastern Colorado and New Mexico, and then northwest Nevada as well. So this is another satellite-based product from NASA. This is their AIRS vapor pressure deficit product. So this signal is just showing over the last 7 days, as of last week, that we're actually seeing fairly wet conditions across much of the region. So again, short-term wetness in a lot of areas, excluding southeast New Mexico, balanced against long-term dryness. And then another similar product over the last 3 months showing this is our evaporative stress index, and again, similar conditions to what we've seen in some of the other indices. Quick look at stream flow here. So this is real-time stream flow as of today for the HCDN network of stations for the US Geological Survey. So these are stations that they have identified as having minimal human interference combined with a long period of record. So we're seeing decent stream flow in some parts of Arizona and New Mexico, while stream flow further north into Nevada, northern Utah, and northern Colorado is still struggling a bit. And then adding in the rest of the stations, you tend to see a similar pattern to that, all things considered. So all that being put together, here's a look at the current US Drought Monitor. This is as of last week, August 2nd, released August 4th. So across the region, we've seen some improvements in southern Nevada and some limited improvements in southern Utah, but we're still mostly looking at extreme and exceptional drought over these 2 states, with some improved conditions in Colorado, New Mexico, and Arizona, where the drought in New Mexico, again excluding the far southeastern and east central high plains, has primarily transitioned now to a long-term drought. So this is a look at how conditions have changed over the last 4 weeks from about the 4th of July to last week. Again, mostly improvements in these areas, but you'll notice that kind of east central New Mexico hasn't seen as many improvements as southern Colorado, other parts of New Mexico. And then we've even seen some degradations in central Nevada. And this map will be updated again in a couple days when the new drought monitor is released. Looking ahead here, we're potentially looking at some continued flash flooding. Both today, there are flash flood watches out for parts of the region, and this is from the National Weather Service Weather Prediction Center, their day 3 through 7 hazards outlook, which was issued yesterday. This whole area highlighted here has a risk, in the opinion of the forecaster, for heavy rainfall. And then this is their 2-week hazards outlook, and similar picture, a lot of the Southwest is looking at a slight to moderate risk for heavy rain associated with the monsoon's continued active pattern. So as we go forward in time here, I'll just mostly, since we kind of already saw data with respect to the last couple maps we've looked at, I'm going to focus on the CPC outlooks for 3 to 4 week precipitation. And we're mostly looking at chances leaning towards above normal precip in much of the southwest, and equal chances for above or below normal temperatures in the southern part of the region, leaning slightly towards above normal temperatures as you head further to the north. Seasonally, the picture gets a bit different. Yes?
Curtis, sorry for the interruption. Are you near your last slide?
Yes, this is the last slide.
Perfect, thank you.
Yep. So seasonally, the picture does get a bit different here. We're leaning towards through the end of October, above normal temperatures across much of the region, especially in parts of Utah, Colorado, and Nevada, and unfortunately below normal precipitation across parts of the region, excluding western Arizona, southern Nevada, and sorry, not western Arizona, all of Arizona, western New Mexico, where you have equal chances for above or below normal precipitation. So I'll go ahead and cut that off. Thank you for your time.
Thank you. Thanks, Curtis, so much. Now we will transition to Dawn Browning to talk about her work with PhenoCams in monitoring drought recovery. If you have questions for Curtis, please put them in the questions box.
I wanted to share my webcam to say hello to everyone. I will turn it off now as I go to change my slide. Are you seeing my presentation slide?
Yes, looks good. Thanks, Dawn.
Perfect, wonderful. Thank you for the invitation, Joel and Emily and Curtis. Thank you for that beautiful kind of overview of not only the conditions, but everything that goes into the drought monitor. That's very, very helpful for what I'm going to be sharing, which is a tool. I'm going to share about a tool with new ideas for enhancing our capacity to monitor drought. And this is a perspective that's more on the ground as compared to, say, satellite remote sensing. So I monitor phenology. That's part of what I'm going to be talking about. We're talking about PhenoCams. I'll define those in a moment, but I want to ensure that we all understand what phenology actually is. And it is the study of seasonal cycles in biological phenomenon, and it also captures the drivers, the relationships between those cycles that we can observe with the environmental and biotic and abiotic factors that drive them. It applies to animals and wildlife and plants, as you can see here. PhenoCams are simply digital cameras that are mounted on towers and pointed at a fixed location close to the surface, as you can see depicted here on the left. And so we're wanting to kind of explore the use of the time series that comes from these cameras that are a few meters off of the ground in most cases, that are also distributed widely across the US, which is what you see with the red dots in the map on the right. So these PhenoCams are contributing data in real time, in most cases, or in near real time, to an online repository, the PhenoCam Network, that is currently housed at Northern Arizona University. And so the utility, I think, of kind of using the cameras and the imagery from these cameras is twofold. One is their time series close to the ground, and secondly is their geographic distribution. To look at this just another way, kind of combining those two things with the size of the bubble represented in the map that you see on the right, that is a kind of representing the number of site years within that general area. So as you can see, the PhenoCam network started in the deciduous forests of the Northeast US and has spread to other sites throughout the United States. And the fairly large dot you'll see in the Arizona or New Mexico area has to do with an extensive PhenoCam network that we have at our research site at the Jornada Experimental Range in Doña Ana County, and I'll be sharing some insights from that site in particular. So this is what the camera at that location looks like, just to provide a visual before the graphics come in. And this is a camera that you see facing north in a black grama grassland. So this area is protected from livestock grazing, and the perennial seafort grass is the dominant, Bouteloua areopita is the dominant species, and it is powered by solar power. This is what that camera actually sees on the ground. And so the really fantastic aspect of this, not only is it that the imagery comes from something that is really what occurs in the mind's eye of many of the producers and practitioners that are dealing with in our federal agencies, as well as individual producers on the ground. But we can identify areas of interest within the field of view of these cameras. And what happens is the pixels within those, much like the satellite remote sensing data that Curtis talked about, there are pixels that constitute this image as well. And so we can summarize the values within a particular area that we want to focus on. And in this particular case, the quantitative time series is a vegetation index that's called GCC, or a green chromatic coordinate. And it is essentially the ratio of green over the sum of red, green, and blue. The one thing actually I'll add that I may not have mentioned is that this is simply, it's a digital camera, much like your phone. These are not highly calibrated instruments that we're using, so they're really inexpensive to work with when considering kind of like satellite constellations of sensors, for instance. So these cameras and the data from PhenoCams have been used extensively. There's already a burgeoning body of peer-reviewed literature that is focused mainly on carbon exchange in deciduous systems or deciduous forest systems. But there have been applications looking at landscape greenness and being essentially that bridge between on-the-ground observations and satellite remote sensing with fluxes of water and carbon. But we haven't really, at this time, looked at how effective they might be in monitoring drought. Can they provide model verification tools for model outputs, and also potentially a cost savings for end users, those individuals that are driving around monitoring drought from their dashboard? And I included this figure from a paper we published in 2016 just to kind of like highlight where the PhenoCams fall in this hierarchy of observation tools that we can use. So questions that we're interested in are, can the PhenoCams detect the plant stress that we are seeing represented or presumed to represent the drought monitor? And how can we best leverage these eyes on the ground to existing drought indicator systems? And so Curtis gave a brilliant overview of the US drought monitor. This is that same map. And there is this warning, I guess, on the, or acknowledgement is like local conditions may vary. And that's an important thing to point out as we're trying to bridge these two data sets together. And that's really kind of effectively represented here. With the drought monitor is something that's reported nationwide on a weekly basis and summarized for easy access of data from their web portal, from the National Drought Mitigation Center at the county level. And yet we're looking at, in this case, data from an individual point on the ground, a tower. And I wanted to point out the cluster of red points here are sites from the research site that we're going to be looking at. So I have essentially one data slide. I pulled myself back because it excites me and hopefully it excites you, but in the interest of time. This again is the image that we're reporting from, right? So that yellow polygon that I showed you earlier is the area that's represented in the slides that I'm going to show here. Whereas on the x-axis, it's time from the end of 2013 through August 1st. And this is a weekly summary of local precipitation. So this site is part of the Long-Term Agroecosystem Research Network, or LTAR, as well as the Long-Term Ecological Research Network, or LTER. So we have a lot of local data that we can work with. So this is what we're looking at here is local rainfall. And if we look at then the pattern in greenness from grass greenness, this is weekly GCC, so it's summed over the week, or I'm sorry, not summed, but averaged over the week. The precip is the sum. A few things jump out. Number one, we have a longer time series here than you may have expected to have. Secondly, there is incredible and highly high interannual variability in greenness that pretty much well reflects the interannual variability in rainfall. And the other thing that I want to point out is that the greenness from the black grandma grassland that we're looking at here is highly correlated with precipitation, which one would expect. So before I show you the drought monitor data, I want to pose a question, and thank you, Joel, for providing the poll that I invite you to participate in. So given the data that we're looking at from the grass greenness, which is the green line, and the calendar years, in the last 5 years, so from 2017 to 2021, which of those calendar years would you anticipate, based on the data that you see here, would have the highest proportion of drought categories indicated? So those darker red numbers that we saw in the previous slide and in Curtis's presentation. So I can't see the poll results or I'll lose my screen share, but we'll give you another little bit of time, I'm not sure. But I'm very, very curious to see what you think. So which of the last 5 years, last 5 calendar years, not water years, would you expect to have a greater proportion of severe drought category as we sum it up? And we can close that poll now, and I'd love to see the results. Or Joel, well, we'll come back to this, I guess, kind of see what the prevailing answer was.
So I am, hi, Joel here, Dawn. I'm not sure if I can share the results, but I certainly can talk you through what we got. Do you want to do that now or wait till after your presentation?
Maybe we'll wait till after. That's perfectly fine. Thank you, though, I appreciate that. So if we look at the drought monitor data for Doña Ana County, so this is at the county level, and what we see here on the y-axis is the proportion of that county distributed across the drought categories from D0, abnormally dry, to D4, which is exceptional drought. So if any of you guessed 2021, that answer is correct. Although, if you look at the data itself, you know, there are some patterns that might not match up. And I think this goes back to the fact that we're comparing point data with county data. And the drought monitor tool in and itself acknowledges that local conditions may vary. So it's the take home from the research question side of it is that GCC may be a better indicator of recovery from drought that we see here in 2021, with this peak in greenness being associated pretty closely with a rapid fall in not only the severity of drought, but the proportion of the darker categories. I think that at this time, from what we can see, the GCC may be a better indicator of recovery, drought recovery, than it is, for instance, in say 2019 of drought itself. And this is not a statement of accuracy about the drought monitor. I want to be very clear in saying that. And we are looking at integrating other data from locally, both at the within Doña Ana County, to explore this further. And that's part of this, you know, analyzing data from other sites, but then also provide or compare essentially with the raster pixel product of the drought monitor and see if that really is the matchup, a mismatch between the county and the point data itself. I want to indicate those that have either discussed these ideas with me or been directly involved in collecting the data that I shared. And thank you for your time. And I would be happy if there is time for questions.
Well, Dawn, I'm going to share the poll results with you. You can look at those and see what people thought and maybe talk through that if you'd like to.
Perfect.
Are you able to see those now, Dawn?
Okay, I'm trying to stop my screen share. Oh, did I stop my screen share? I did, right?
I can't really tell because I'm showing the poll. So we both can't really tell. But I could just walk through. I think the audience can see the poll results right now. Of the respondents, 44% thought 2020 was going to have the highest proportion of drought, and a quarter, 25%, thought 2021 would.
Okay.
So that's how it ended up.
Yeah, no, that's very, it's always great to kind of see what people are thinking. And so again, no one's actually wrong. This is essentially, we're comparing in some cases when we consider the area that we're representing in both of those products, that there is a bit of a mismatch that we are exploring how we might rectify in the future. So.
Okay.
Hopefully I stopped my screen share.
Yes, it looks like you did.
Okay, thank you.
And I think we'll just move directly into the questions portion, unless Emily wanted to say something before we did that. I'll give you a chance to speak up if you did. Otherwise, I'll just take over. So this is Joel Lisenby from NIDIS. I was going to be managing the questions. I'd like to acknowledge that we are just a little bit over time, but I'm also going to acknowledge that right now I've got some really interesting questions that I would like to ask of our presenters that have come through. So if you can stay on just a little bit longer, we'd really appreciate that. The first question that I'm going to ask is going to go to Curtis. This one comes from Peter in Gallup, New Mexico. And he says, Curtis, are we able to make some predictions for winter precip yet? How well can we look at what's going on in winter, or what's going to happen?
Yeah, Peter, thanks for the question. Not being a forecaster myself anymore, I haven't looked at that personally. I can say I've at least heard rumblings of that we might be still looking at La Nina conditions going into winter again, which would tend to lean towards drier than normal conditions across a lot of the south. But I'd refer to CPC outlooks for that, which I don't have in front of me right now. I will try to dig some of those longer term outlooks up while we are still on during the question session though, and see if I can answer that for you.
All right, thank you, Curtis. The next one, I'm going to bounce over now to Dawn again. I'll come back to you in a minute, Curtis. So Don, Joe says, first of all, great presentation, thank you. And he wants to know how well correlated is the GCC with accumulated, oh, I can only see a part of that question. Let me make that bigger. Accumulated weekly rainfall. So the GCC correlated with weekly accumulated rainfall.
You know, that's a great question. And that would, I actually don't know, but it is certainly something to explore. That is something, and even with accumulated heat, kind of for a similar reason, we haven't looked at that quite yet. These are somewhat hot off the press, and so I will definitely take a look at that. But I imagine that it is potentially better correlated given the fact that the grass greenness occurs at a distinct point in time, whereas if we were just looking at general landscape greenness, the grasses don't respond as to winter rainfall per se. So I will take a look at that. I appreciate that question a lot. Thank you.
Thanks, Don. Another one for you, Curtis. It's also looking ahead, but not quite as far as winter. Do we have any idea yet, given the active monsoon, but also the projections for warm and dry conditions heading into late summer and fall, what soil conditions in the Colorado River Basin might be like heading into the next water year? So that's beginning in October. I'm wondering whether the active monsoon may be giving us a really needed boost, or whether it could just turn out to be a drop in the bucket, like you mentioned. That was, he says, thank you. That was from Tom.
Yeah, thanks, Tom, for the question. The short answer to that is that I don't know, as I'm not a hydrologist per se and a soil scientist. I can tell you based on some of the data products that I've looked at recently while doing the drought monitor that I think we've seen some soil moisture recovery with the current monsoon, and so that as long as it stays active locally might continue to recover. How exactly well that's going to hold when temperatures may stay above normal as we go into the latter part of 2022 here, I don't have a great answer for that.
All right, thank you, Curtis. So there's still a lot we don't know, is what I'm picking up.
Right, and there might be better people than me to ask that who may be able to give you a higher confidence answer. So,
okay. Here's another. Sorry, were you going to say something else?
Oh, I found the December through February maps that
sure.
gentleman asked about earlier, yes, as I had suspected, most of the southern U.S., including most of New Mexico, Arizona, southern Utah, southern Nevada, southern Colorado, lean through for December through February towards below normal precipitation and above normal temperatures. So again, that's a relatively long range outlook, but as of July 21st, that was what CPC had for that period.
Great, thanks for digging that up in such short notice there, Curtis.
Sure.
That was great. The next one is, I'm going to go back to you, Dawn. The question is, if you take a photo of a green plant, what is the moisture content? And you calibrate greenness to moisture content. Is that something that you can answer?
I think you could definitely do it. It could definitely be done, but you would need to use a different instrument, not the PhenoCam, for instance, or the digital camera model that I'm using, for instance, and described here. But there definitely are instruments that can be used, potentially even some of the most recent cell phone cameras, in fact. And I know that there's been really great work done by Jeff Herrick and his group with Land PKS to look at soil properties based on a photograph. So it would be a similar relationship, I think, between soil moisture and texture with a photo as you could potentially derive from an image of a green plant.
Okay.
So it's doable, but with it would definitely, I think it would require a different instrument or a calibrated instrument.
Got it. Thanks. There's one more question for you, Dawn. This is probably the last one that we'll have time for. Have you ever looked at the drop in groundwater levels in relation to greening factor or plant conditions due to the puric, I hope I'm saying that word right, puric nature of the plants? You can tell I'm just asking this question. This is outside of my expertise of what's happening here. Over time, we see the decline in groundwater over locations experiencing years of drought. It was just finishing up there.
You know, I think that's a fascinating question that we could look at, and I think it would probably be most effectively answered. So I have not to answer the question directly, but I love the idea and I appreciate the question, and I think it could be really helpful, and someone may already be working on this in cropping systems, right? Where there's more heterogeneous or at least a substantially greater proportion of the ground that is covered by vegetation. I think that would be definitely an important factor in the strength of any relationship between groundwater depletion and plant status. But that's a great question. I appreciate that a lot, actually.
Okay. Just for my benefit, because I feel like I'm out of place here, do you know what the word puritic is? Can you explain that to me?
Puritic? I actually don't, and
Okay.
I'm not familiar with the term.
Okay. I thought, so Cynthia who asked that, I'm sorry for butchering that question. Please forgive me.
You're also talking to a visual learner, so if I saw it written or I would know.
It's Dawn, it's phreatic. The question is phreatic. So
thanks, Emily.
Related to
Thank you,
Emily.
I'll Google that one later. That's all the questions. I'm going to pass back to you to close us up. Thanks, Emily.
Well, thanks everyone for attending. We will have another drought briefing next month. And this concludes our webinar.